In this part of the podcast, I'll talk about important types in Haskell. And for each type that I'm going to talk about, I'll provide examples of expressions that have this type. And, moreover, I present the type rules that are associated with this particular type. There's an important distinction that we have to make. It's a distinction between simple types and composite types. Simple types are types that are not built from other types. An example of such a type would be the type bool. Another would be the type int. But other types are composite types, and they're types that have simpler constituents. They're built from other types. An example is the pair type bool, int, the type of pairs whose first component is a boolean and whose second component is an integer. Another example is char list, list of characters. So here we see that the constituent of char list is char, and here the constituents of bool, int are bool and int. So those are simple types. These are not to be confused with simple and composite terms, because that's something else. Very often, simple terms have simple types and composite terms have composite types, but it's not always the case. In what follows, I'll be presenting some type rules. And type rules speak of type judgments. And type judgments are of the form: given some type environment, expression E has type T. So this is a type environment. Now what is a type environment? A type environment is a function E from the set of variables to the set of types, and it's a partial function because it's not necessarily the case that every variable is given a type, but if we have that E of x is T, means that E gives the variable x the type T. So our type rules that we'll be presenting in a little while speak of type judgments, and these type judgments have to be relative to type environment, because an expression E may contain variables. So in order to find the type of variables, we need to look them up in the type environment. To understand the need for a typing environment, let's see how we type variables, because expressions can contain variables. So the type rule var for variables is a very simple one. If we want to type in a type environment a variable x, then x has type t if it's the case that x has type t according to E. So here the side condition is that if we look up x in the type environment, remember the type environment is a function, so we can apply the function to x, and if we then get t, then x has type t. So that's where the type environment comes into play. Let's get started with some simple types. Let's look at numerals, booleans, and characters. Now, for numerals, it's the case that there's more than one numeric type in Haskell. Each of the numeric types belongs to the type class num. So the type int is in the type class num. The type integer, which is a different type than int, is in num. The type float is a type in num, and the type double is a type in the type class num. Remember, a type class is a family of types. Every numeral n has type, and this is interesting. It has the type num a to a, meaning that for any type a, if a is a type in numeral, then n has type a. How do we write that as a type judgment? We write it as follows: that in any type environment E, n has type num a to a. There's a smaller type class called fractional, is the type class of numeric types that correspond to decimal numbers. So it's not the type class of decimal numbers, the type class of types that correspond to decimal numbers. Now for Booleans. Booleans have type bool, and we have two type judgments. One says that the constant true has type bool, and the other says that the constant false has type bool. And of course these judgments are irrespective of the type environment, because true and false do not involve variables. How about characters? Well, characters, they're written with single quote marks, and they have the type char. For instance, the letter H, written in quotes, has type char. So those are the simple types that we have in Haskell. We've got numerals, booleans, and characters.